All right. Hi everyone. This is Marcus. I guess the team might miss communicate in terms of the title. I'm actually Marcus from Microsoft Singapore. So I'm going to talk about machine learning ops. Basically, it's an enterprise ready DevOps for machine learning platform over here. So as more and more customers start to embark their digital transformation journey, a lot of them start to think about using cloud technologies or using even DevOps to increase the agility on delivering the values to their customers, right? So in this case, along the way, a lot of customers start to think about, hey, you know what? Since I'm already practicing DevOps for my application delivery, how about I start to infuse the DevOps into my machine learning project, right? So as you are aware, machine learning AI is the next big thing that a lot of industries are looking forward to, right? So here it goes into, unifying the DevOps and machine learning, and this is where MLOps will come into picture, right? So for today's session, I'm going to share with you a quick run through on this enterprise ready DevOps for machine learning. All right. Now, just a quick introduction about myself. I'm Marcus T. I'm actually the solution architect in Microsoft Singapore. So I mainly deal with public sector in Singapore over here. Right. So let's start with a background on this machine learning project, right? A lot of time when people start to ask about, what do you think about a machine learning project, right? A lot of time, right, we may think that, I have a lot of data. I put into the algorithm, right? Or sometimes people just call it a black box, right? So I have my training data put into this black box, and after that, perform all my training, data cleansing or whatnot, and I'll then produce a model itself, right? And as and when I have new data coming in, then obviously I'll go through the same, same black box or same approach, right? And it would then produce a better model, right? So a lot of time people start to think about, this is how the so-called machine learning project looks like, right? But in actual fact, right, in reality, for those who are involved in the machine learning project, you will know that, it's not just that simple, right? I have data, I put in a model, I put in the algorithm, and then I'll generate a model, right? In reality, the entire machine learning project is way more complicated than what we imagine over there, right? So let's think about, what's the process on building a model over here, right? Now, so obviously, we only see this building a model, right? So this is the so-called simplified version that I mentioned just now, right? But behind the scenes, before we are able to derive a model, right? These are the various stages that it will go through, right? So first thing first, we did need to look into how do we acquire our data, right? How do we make sense of our data? And after we perform the so-called data ingestions and analyze the data, we would then need to do the data cleansing, right? Because as you know, right, if let's say the data is not structured or not cleansed, right, basically it's a rubbish in, rubbish out. So a lot of time, the data scientist or even data engineer will spend a lot of time on doing the data cleansing, doing the data transformations, or even doing the data validation. For example, a common scenario, let's say, let's talk about, the unit of the data coming in, the date format, right? So all this kind of data, we would then need to perform validations, and obviously we also want to remove, let's say, duplications, or we want to remove those empty entry, right? So there will be a lot of effort required when data coming in to perform this data cleansing. And after that, this is where we only start to think about the machine learning project, where we start to split the data, do the training, do the model, and then do the so-called model validation, right? But obviously, after I have a model, my the job doesn't stop here, right? Because after that, I'll then need to think about how should I roll out my model, how should I serve my model so that my application can integrate to it, and how do I perform the maintenance, right? Meaning, how do I monitor the performance of my model? Is there any drift in the performance? And obviously, I want to perform the logging as well. So as and when there's issues on the data itself, on the model itself, we will be able to re-trigger the entire thing, right? So as you can see over here, doing a machine learning project is obviously not that 3 steps that I showed in the previous slide. There are a lot more steps involved over here, right? So this is just one of the tweet that I find it quite interesting, right? The story of an enterprise machine learning, right? It took me 3 weeks to develop the model, right? It actually it had been more than 11 months and it's still not deployed, right? Basically, this shows that, developing the model is easy, but, the steps in front and the steps after that is the complicated one, right? So obviously, when you look into this project, this entire machine learning project itself, when I go through the flow, you know that it's not just about data scientists, right? A machine learning project is not just about data scientists, right? If you take a bird eye view on what are the so-called stakeholder get involved in the end-to-end successful machine learning project, right? So obviously, we will start with a business owner, right? Where the business owner will have their business questions, right? Their goals, and what are the challenges that they are facing and what they want to try to achieve, right? They will have a problem, right? And this is where we'll go through a discovery stage, right? Where either the data analyst or the data engineer will start to do the data discovery based on the data acquisition. They will then do the data explorations and obviously also do the data preparation, right? And once they understand the data set itself, this is where the data scientists, right, will start to come in and start to do about this model building, the model assessments, as well as a model deployment, right? So basically, I call this an experiment stage, right? But obviously, within this experiment stage, it's also not just about data scientists, right? Because the business owner is also involved, right, to validate that, make sure whatever so-called output that the data scientists are producing will be able to meet the so-called business objective over here, right? So as you can see, just in this discovery and the experiment stages, there will be already various stakeholders get involved in this stage itself, right? Now, so assuming that everyone is happy with the model, both the business owner, the data scientists, they have optimized the model, right? And this is where they will then need to think about how should they deploy the model, right? Be it I deploy as a REST API, I deploy like a library, or how do I want to load balance my APIs? How do I perform the logging, all these things? And this is where the software engineer will come into picture, right? To actually take over the data scientist to deploy the model, right? And obviously, we will then go through the stages of operationalized stage as well, right? Because as I mentioned just now, the model, after I get deployed, it doesn't mean my job stops there, right? I'll still need to monitor the performance of my model, make sure that I do have the options to do the necessary auditing as well as reporting, right? So in this case, the data scientist would then work very closely with the software engineer, right? So this is a very generic bird eye view on what are the stakeholders get involved in a end-to-end successful machine learning project itself, right? And this is where, as you can see, as you can imagine, right, for those who are involved in a software deployment, right, with so many stakeholders get involved, there will be a lot of so-called handover required, right? And this is where DevOps come into picture to help to address the application deployment. And obviously, in this case, MLOps will come in to actually help to address, the so-called handshake between all these various stakeholders, as well as streamline the deployment itself, right? Now, so what do we mean by MLOps, right? Basically, it's a machine learning plus devs and ops, right? So within a machine learning project context, what do we mean by development, right? So obviously, in this case, we spoke about the experiment using the data, right? For those data scientists who are very well versed with Python, Jupyter, these are the common tools that they use to do the so-called experiment, right? And they also do the so-called data retrieval, having the business understanding as well as the initial modeling, right? So this will form within the so-called development stages itself, right? And when we look into the so-called operational side of the things, right? So this is where not just about having this model get built, but also a streamlined method where we can deploy, or rather we can make this model production ready to be deployed and integrate with the applications, and obviously establish a data feedback loop, so that as and when there's anything happen within my applications or within my model, I will be able to close the loop to either retrain the model, acquire new data or whatnot, right? So this will be how the so-called MLOps come into picture, right? For those who are familiar with DevOps, you might see that they are quite they are high level of so-called similarity over here. All right, now so let's talk about some of the so-called benefits, right? Why why some of the organizations, they are looking at having an MLOps for their machine learning project, right? So in general, I will actually summarize into these three categories over here, right? The first one is on the automation or the observability, right? As you can see over here, just now when I talk about the process, right, all the stakeholder, right, there's so many stages involved. And you know what, if there's one, at one of the stages, right, there's a new requirement, right? And this is where we want to ensure that whatever that the people build, right, can be automated and can be reused, right? This will actually streamline the entire deployment itself, right? And having a reproducible pipeline is not just about automation, right? More importantly, it's also for the so-called auditability, right? So I think later I'll talk a little bit more on this portion, right? And on the second so-called benefits is really on the validation, right? So within the so-called software engineering background, as a best practice, a lot of time we will do the so-called quality control over here, right? And over here with MLOps, we will be able to enable, we will have the so-called quality control within our machine learning model itself, and we will be able to minimize the bias and provide the descriptiveness, right? So which means that as and when there is a new model coming in, we are able to do the versioning, and we'll be able to validate whether this model fulfill the so-called requirement that a business owner or even the so-called non-functional requirements over there, right? So this will be the second benefits on the validations, right? And the third portion, right, is quite similar to the first one on the reproducibility as well as the auditability itself, right? But I just want to point your attention to the last 2 pointers over here, the live comparison of a predicted and expected performance, as well as the results of feedback to monitor, drift, and improve the model, right? It's a common scenario whereby when I have a model, and as and when I start to consume the model, right, there is a possibility that my model will drift, right? It could be due to the fact that the nature of the data change. It could be due to the fact that the so-called entire business environment change, right? So all these so-called component will actually cause the model get drift. And in this case, it doesn't make sense for us to reuse the same model, right? Because it would then produce the output that might not be favorable in the business context, right? So this is where we will need to ensure that there is a monitoring capabilities to ensure that we will be able to feedback the so-called model drift into the entire pipeline. And back to the point number one, where I have a reproducible pipeline, as and when I detect there is a drift in my model, I will be able to re-trigger all my pipeline to perform all the training again, right? So this is some of the major benefits within MLOps, right? And essentially, right, to summarize the benefits, it will be having the velocity as well as the security for the machine learning project, right? Now, when we think about the MLOps platform, right, it's not something that very far-fetched, right? In fact, you can always start to build your own machine learning ops platform, right? So basically, there are only a few key components, right? The first one is the machine learning pipeline, right? Whether you're using Azure Machine Learning or whether you're using Kubeflow, right? And the second component is on your code repository, right? And obviously, there are so many options that you can consider: GitHub, GitLab, Bitbucket, whatever tools that you like, right? And obviously, the third component, right, is the CI/CD pipeline, whether you are using Azure DevOps, Jenkins, Bamboo, or whatnot, right? So if you think about MLOps platform, right, it's not something that is proprietary to a particular provider. In fact, it really based on the tools that you are familiar with, and you can actually stitch all these things together to build your own machine learning MLOps platform over here, right? So just to contextualize the MLOps workflow, right? How the so-called application developer and the data scientist, right, collaborate together using all these different tools, right? So let's start with, on the left-hand side, I have my application developers as well as a data scientist, right? And over here, the data scientists, after they are comfortable with the experiment, this is where they would then commit the code into the code repository, right? Whether it's the so-called Python code or whether it's a data set, right? They will be able to so-called commit all these things into the Git repository, right? And the moment they commit, we will enable the model reproducibility, because for those who are familiar with a Git, there will be a so-called Git commit history, and I can always trace back to the so-called history based on what the data scientist has been committed, right? And second thing, after I have my data set as well as the pipeline, and obviously in this case, I will be able to start to trigger the model training process over here, right? Whether we are using the machine learning pipeline that we created, or whether we're using automated machine learning, right? That's all the options that we can use over here. And last but not least, on the hyperparameter tuning, right? And thirdly, right, after we have created a model, and obviously we will then need to validate the model itself, right? We want to make sure that the model actually meet a specific requirement. For example, whether we are looking at accuracy, whether we are looking at a root mean square error, right? We will need to define a so-called parameters for us to do the model validations itself, right? And after we pass the so-called validations, this is where we will then be able to deploy the model, right, into the field so that the respective applications can be integrated to leverage on this machine learning algorithm, right? And lastly, when the model is running, I'll need to make sure that I do have the so-called monitoring capabilities. And as and when it crosses a certain threshold, I will be able to trigger the pipeline to retrain my entire model again, right? So this is in a bird's eye view how the workflow will look like between the application developer as well as the data scientist, right? So a lot of talking, right? What I intend to do is that I'm going to walk you through, right, a quick demo on how the MLOps will look like. And obviously, I'm actually taking a reference within the GitHub repository, right? So for those who are interested in, you can actually go into the GitHub, right? And it's public, and you can start to use it as a template, all right? Now, so without further ado, let me go into my browser. All right. Now, so what I did over here is that, in this demo, right, I'm just doing a very simple scenario, right? I have my data on a CSV based on a diabetes informations, and I want to create a regression model, right? So which means that I want to be able to so-called predict the probability that this person has diabetes over here, right? So, just now I show you the GitHub repository. So what I did is that I actually clone a copies over here, right? So there'll be a lot of documentations that you can follow, right? So what I'm going to do is that I'm going to walk you through on these portions over here, right? So let me switch over to the code view on all these things. All right, so I'm actually in my GitHub code space over here, right? Just to show you how the so-called data will looks like, how the pipeline looks like, and what's the difference between the so-called normal workflow and the MLOps, right? So first thing first, let's look into the so-called data set, right? It's a very simple data set, as you can see over here, basically just a CSV data set. And these are the headers. And obviously for demo purposes, we don't go through we skip the data validation as well as the data cleansing, right? So we straight away do the so-called scaling of our data, right? So basically this is our data, right? Now, so for those who are familiar with the so-called machine project, it's quite, you may see a lot of familiarity over here, right? Under my so-called train script over here, I'm using the scikit-learn, I split the data, I train the model, I have the model, then I sort of like print out the metrics, right? So this is I would say a fairly typical way for the data scientists to perform the experiment within the using the so-called data set, right, over here, right? Now, so let's think about how can we integrate MLOps into this workflow over here, right? Now, so first thing first, right, instead of doing this within one single file, what we're going to do is that we're going to segmentize all these things into a pipeline, right? So if I switch over to another tab over here, right? As you can see over here, I'm using Azure Machine Learning Service as an example. And over here, what I do is that maybe I'll just scroll down, right? Over here, right? So what I did over here is that I define the pipeline over here, right? So instead of having one master Python script to perform all these different activities, I actually break down into 3 different stages, right? So the first stages will be training the model, pointing to a particular script, right? And then I'll have my evaluate model, again pointing to another script, and the third one registering the model, and obviously pointing to another script as well, right? So if you recall, just I spoke about the reproducible pipeline, right? So this is the pipeline that we mentioned over here, right? Now, so after I break down into this pipeline, this is where I will then start to bring in the DevOps component in already, right? So within DevOps, we are familiar with CI and CD, continuous integration and continuous deployment, right? So let's take a look on how the continuous integration looks like in MLOps, right? So over here, I'm using a YAML to actually define my continuous integration pipeline over here. So I know there's a lot of text, but later I'm going to show in the portal, but I just want to quickly walk you through on how does it looks like, right? So over here, I'm defined that this is my model CI, right? And you will see that I have a different stages over here. And one of the stages over here is actually to trigger Azure Machine Learning pipeline to perform my training and evaluation of my model over here, right? So I'm not going to bombard you with all these things, but basically within my continuous integration, I will use my pipeline to trigger the training, right? And after I finish my training, and over here, I'll then do the continuous deployment, right? In this case, I'm just doing a very simple example where I'll deploy the model into Azure Container Instance, right? I mean, container is kind of a simple options for us to deploy the machine learning model itself, right? So this will be all my so-called various options on my continuous delivery pipeline, right? So let me switch over into my so-called pipeline, right, to show you how does it look like before I move on to the Azure Machine Learning portal to show you how it is in action, right? So just now I walk you through the CI, right? This is the continuous integrations that I mentioned, right? If I click on one of the steps that I run over here, right? So obviously these are the various steps that we perform over here, right? I do the so-called lean test, unit test, and then I trigger the machine learning pipeline over here, right? So this one will be my continuous integration, right? And if I go into my continuous deployment, right? Likewise, you should expect kind of similar steps as well. Maybe I'll just quickly walk you through, right? When I actually download the pipelines, install the command line, deploy into the Azure Container Instance, and I even perform a smoke test, right, to ensure that the model that I deployed will meet my requirement. And after that, I will be able to validate through my command line, right? So this will be how my so-called CI and CD pipeline looks like. So maybe let me switch over to the so-called Azure Machine Learning portal on how it looks like in behind the scenes, right? So let's start with the so-called data set over here, right? So in actual fact, when we are looking at the MLOps, one of the very important elements is to ensure that we are doing the versioning of our data set itself so that we are able to so-called re-trigger the pipeline based on the same data set, right? So as you can see over here, this is the CSV file that I showed you just now. And I sort of like do a versioning over here, right? And obviously, I will be able to explore my data set over here so that I will know is there any missing column, what is the profile of my data sets over here. All right, so after my data set, just now I spoke about the pipeline, and this is how the pipelines will look like, right? Maybe I'll just show you, right? So if you recall just now in the script, there are 3 different stages over here. In fact, behind the scenes, this is what are the various stages, how it looks like. And each of them is corresponding to a particular Python script to perform the activities over here, right? And as you can see over here, right, how long it takes to run and all these informations get so-called tracked out over here, right? And, just now I spoke about all the metrics, right? In fact, it will then captures over here, right? And after I'm happy with the model, this is where I'll then need to register my model and do the deployment, right? And over here, in this case, is a very simple model. And, for those who are familiar using a scikit-learn, the output is actually a pickle file. And over here, I'll just, using the automations to deploy this model into a container instance itself, right? So how does it look like? So, as the end-to-end automation, this will be the end state that it will produce, right? I will have a URL that actually contains the model, right? So you see, you start to accept the HTTP request over here. So obviously, in this case, it's know that, it is in a healthy stage, right? So maybe what we can do is that we can do a quick test, right? We just do a HTTP post to do a scoring over here, right? So in this case, I'm doing a post to this URL, and these are the so-called sample data that we have. And, as expected, when we send out the data, we'll be able to get the results over here, right? So how this is how everything stitched together from a so-called tooling perspective. When we look into all this code over here, it will actually get automated and deployed into the various components that I've shown you over here. All right. So maybe let me go back to the slide itself, right? And just to recap on this portion over here, right? We have shown you using the GitHub as my code repository, and I've shown you using the Azure Machine Learning Service as well as Azure DevOps to actually perform the build and the training in an automation manner. And I also show you how we use an Azure Container Instance to deploy the model. And lastly, we'll be able to monitor the performance of our model itself, right? So hopefully this will give you a quick view on how on the concept of MLOps, how does it look like, and what are the so-called tools available to perform that. All right. Now, so we spoke a lot on, reproducibility, gaining the so-called agility via the MLOps, right? But more importantly, right, it's not just about giving us the time to market, right? Giving us the so-called agility to deploy or rather to update our model faster, right? But more importantly, MLOps allow us to establish a clear, responsible AI approach, right? Now, when we think about AI, right, this is one of the books that I came across, which I think is a fairly good book to talk about, what's the future, or rather how to be a human in the age of AI, right? So in this book, the author sort of break down into 3 different stages, right? Life 1.0, simple biological, life 2.0, which is where we are on the cultural aspect, and obviously life 3.0, where the technological come into picture, right? And this particular statement really strikes me, right? There is a non-negligible possibilities that artificial general intelligence progress will proceed to human levels and beyond, right? So the questions would then be, how do we design the future with the coexistence with AI, right? So then this is where we'll start to think about, why do we need to think about the responsible AI portion itself, right? So if you think about the so-called role that technology is playing, right, the more powerful the tools, the greater the benefits or even the damage it can cause, right? And obviously we can't stop the technology innovation, right? So we are in these COVID situations. For those who are aware, you will agree with me that, the past, few months actually accelerate the digital transformation, right? And obviously this trend will not stop, right? So in this case, when we ourselves looking at the technology, we really need to think about how should we think about making use of the so-called technology to really benefit ourselves, right? So this is where we start to have a branch on this entire chain of a responsible innovation, right? And this is just a general survey that we work across different organizations, right? When we ask them about, what are the so-called different considerations when you're investing in AI and machine learning technologies, right? So obviously, if you look into the left-hand side, right, not surprisingly, data security, privacy, transparency, these are some of the concerns, right? If you look into the right-hand side, the decision criteria, right? Algorithm explainability, even the skill sets within the organizations, right? So these are some of the so-called top of mind for the organizations when they're thinking about, how do they want to invest the so-called AI and machine learning technology within their organization itself, right? So this is where we then need to think about how do we put the responsible AI into practice, right? So first thing first, right? We would then need to think about principles of our AI or even machine learning algorithm itself, right? So this is an example on how we think about the so-called responsible AI in the principles, right? We can think this is just an example. We can think about having a fairness, accountability, transparency, inclusiveness, reliability and safety, as well as privacy and security, right, within the principle of the responsible AI itself, right? And having just a principle is not enough, right? Just having something on paper or just something that you can talk through is definitely not sufficient, right? We'll then need to look into how then we will be able to put all these things into a practice, right? So when we think about practice, right, obviously we would then need to look into human AI guidelines, right? Conversational AI guidelines, right? A lot of organizations, they start to think about putting chatbot, right? In that case, how do we want to ensure that the chatbot is actually representing the organizations in a fair manner, right? Again, there will be a lot of guidelines that we also want to establish, right? And third component, how do we ensure that we do have the inclusive design guideline over here, right? And inclusive over here, meaning that we want to ensure that the model, right, will be able to cater to all the users, right? We want to avoid situations whereby, the model maybe work best in a subset of the group, right? But it doesn't work for another group, right? And obviously, this design is not inclusive, right? And we may also want to look into a AI fairness checklist, right? How do we make sure that the algorithm that we created is actually following the fairness, or rather the so-called principles that we define, right? And and obviously the last point is that the data sheets for data sets, right? Obviously, data sets is a very important element within the entire responsible AI itself, right? And just now earlier on I spoke about, right, if let's say the data is not clean, right, rubbish in, rubbish out, right? And obviously, how do we ensure that the data sets that all the so-called data scientists are using is a so-called validated data sets, right? Again, we may want to think about how do we do the profiling of our data sets so that when the either the data scientists or whoever that come in will be able to know that, okay, this is the data sets, this is the so-called profile, what are the data lineage looks like within this data set, so that when they are performing the training, they will be able to factor all these different considerations, right? And obviously, have putting in practice is not sufficient as well. We also then need to look into what are the different tooling that we can consider to put into the entire practice as well, right? And obviously, the tooling will then need to be able to understand, right, the algorithm itself, protect the users, and last but not least, giving the control to the developer itself, all right? And the last pointer, right? So we spoke about the principles, putting it in practice, right? Having the tools, right? MLOps can be one example on the tooling itself, right? And last but not least, right? We may also want to think about having a governance body for the project itself, right? And within this governance body, right? I mean, we may start to see there will be a lot of different roles, right? Different new roles are coming up within the organizations, right? In this case, it could be something like a chief responsible AI officer, right? Or it could be, as an example, within Microsoft, we do have this responsible AI office, right? As well as a responsible AI committee, right? So as and when we want to start to embark a new machine learning project, right? At least we can go through this committee to ensure that, whatever projects or initiatives that we want to go through actually follow the principles that we define, right? And last point would be perhaps having a AI handbook, right, for the developers or even for the data scientists, for them to reference when they start to develop all these projects itself. All right. So within the tooling, right, just now, we spoke about the MLOps, right? If we take a one step back, right, within the tooling itself, it actually playing three different roles over here. The understanding portion, right? Understanding meaning that understanding the performance of your model, right? Your model should not be treated as a black box, right? Because ultimately the model is assisting the human to make a decision, and we ourselves as a human need to ensure that we know the rationale of the algorithm itself, right? So when we think about the responsible AI tooling, we need to ensure that the tools allow us to have this fair learn as well as interpret ML capabilities within it, right? And the second portion is on the protect side of the things, right? I just want to point our attention to the confidential machine learning, right? Often a lot of times when we think about creating a algorithm, right? And sometimes to improve the performance, right? The algorithm may involve a lot of PI information, right? And how do we want to make sure that when we are doing the so-called machine learning training, right? This entire workload is running in a confidential computing, which means that the data not just encrypted at rest as well as in transit, right? This confidential ML allow us to ensure that even the data is get encrypted during the training as well, right? Obviously, these are one of the so-called areas that we can start to explore to really protect ourselves, right? On or not just ourselves, but also our customers on their data itself, right? And the third pillar is on the control, right, which is MLOps that we spoke about just now, right? So as you can see over here, right, I mean, having MLOps is also not sufficient, right? While MLOps playing the role of a tooling, right, there are obviously other components that we need to factor in to enable the successful responsible AI approach within the organization itself. All right. Now, so some of the so-called takeaways are over here, right? The first thing, right, MLOps bring the software engineering best practices to ML project, right? So when we talk about the software engineering best practices, we talk about, the agility, we talk about the Git commit, the history, the ability to goes back to the so-called history. And obviously, before we deploy the model, we will do the validations or all these things, right? So whatever best practice that we have within a software engineering, through MLOps, we'll be able to bring those goodies into our machine learning project itself, right? And, I spent like a good 10 minutes just now to talk about the responsible AI. Obviously, MLOps really play an important component, right? Play a very important role in the responsible AI portion itself, all right? Now, the third point, right? I think this is something that I brought up in earlier on, right? A successful machine learning project is not just about data scientists, right? Data scientists itself is just looking at one particular area, right? Obviously, if I take a bird's eye view, there will be, a successful machine learning project will involve multiple stakeholders over here, right? And last point, right? Although in the demo, I'm using GitHub and Azure Machine Learning service over here, obviously, this is not the only tools that you can use, right? Obviously, you can always build your own MLOps platform, right? Using the open source tools or even, right, using a various cloud platform to really kickstart the journey, right? So I hope for the past, 40, 45 minutes will give you a good perspective on MLOps, a quick run through on how the MLOps looks like in the implementation and some of the key considerations within the responsible AI, right? So with that, right, I actually open up for Q&A, right? And for those who have questions, right, feel free to put it in the chat or something, right? The team actually putting some of the questions over here, right? So the first questions I have is maybe let me read out, right? Is there currently an industry recognized guideline or checklist for AI, for example, AI handbook or standards equivalent at the ISO level, right? Now, to be honest, this is a very good question and a very, I would say, a forward-thinking kind of approach, right? Now, at this moment, there isn't a so-called like a ISO 27000 kind of a standard per se, but I would say that a lot of organizations start to think about this guideline, and they do publish some of this guideline into the into the community itself, right? Ultimately, although there isn't a so-called industry standards to follow per se, but I believe that at least for those customers who are really serious about the machine learning, right, there are a lot of so-called materials that we can take reference in the internet to actually define your own standards within your organization itself, right? Because obviously, different organizations may have a different requirement, right, or even tolerance on the so-called machine learning algorithm itself, right? So, for example, let's take a healthcare and let's take a transportation, right? I mean, these are the so-called critical industry, and obviously the threshold or even some of the so-called guidelines that they set will be fairly quite different, right? So unfortunately, at this moment, there isn't a so-called ISO kind of standards, but I would say there are a lot of so-called materials available in the on the so-called community for us to kickstart the entire journey, all right? And second questions, right? In government agency context, is there any use case where Azure DevOps is better than GitHub Enterprise server repositories? Would like to know about Azure Pipeline, Azure Repos, and Azure Artifacts, right? Now, just a FYI is that Microsoft actually acquired GitHub, so we do own a GitHub in this case, right? But over here, one of the things that I just want to point out is that within Azure DevOps is provide as a SaaS, software as a service, And for GitHub Enterprise Server, it will be provided as a server hosting kind of a model, right? So what it means to agency is that, for those who are so-called quite familiar with the GCC context, right? Then you know that, one is a SaaS, one is something that you can deploy either in GCC or on premises, right? And obviously the GitHub Enterprise Server will give you more flexibility in terms of where you want to deploy, whereas the so-called Azure DevOps as a SaaS will so-called remove the headache, right, on maintaining the entire platform itself, right? Now, over here, I would say that between Azure DevOps and GitHub, they do share quite I would say a high level kind of a similarity in terms of the core capabilities, right? In the so-called MLOps context, when we think about the Git repository within Azure DevOps, we will have the Azure repo. Within GitHub, then obviously, we do have the so-called Git repo over here. And just now I spoke a lot on the pipeline, right? And for the demo, I'm using Azure Pipeline. And obviously, you can also use a GitHub action to so-called represent your CI/CD pipeline on your MLOps workflow, right? And Azure Artifacts, likewise, within GitHub, you have the GitHub packages, right? So ultimately, I would say that it really depends on the so-called comfort level of the developers as well as the so-called data scientists, what are the tools that they like to use. And obviously, then we would then be able to direct them to the respective components over here, right? Now, if you ask me, is there any so-called use cases on so-called ML ops within the government industry itself, right? To be honest, I think it's kind of like a early stage that a few agencies, they are already start thinking about that, right? In fact, there are a few agencies who are quite advanced in the DevOps pipeline, right? They are already setting up a team to actually think through how should they think about the ML ops, right? So I would say, maybe not in production yet, but there are quite a fair bit of agencies already start to explore these ML ops within the agency context. All right. Yeah, this is the two questions that I have. Just wondering, is there any additional questions or is there any, specific things that you want me to walk through? I think we still have about 15 minutes to go. All right. So there's a questions on how are ML ops models stored in a database, right? Any recommendations like a MongoDB or something, right? Now, I would say this one really depends on your the context as well as the data acquisition strategies that you have with this entire project itself, right? Because I do encounter some scenarios whereby their data set is relatively static, right? For example, you'll be get stored in a CSV file, and sometimes they just store in an RDBMS or whatnot, right? So I think it will. I mean, the first point of consideration is really how your data is being acquired, right? Before we look into the so-called how the model is being stored, right? So because we do have some of the scenarios whereby the data is static, we do have some scenarios whereby the data is dynamic, right? Meaning that the data keep having new entries or keep updating over here, right? So after we have so-called do the profiling of our data set on the nature of the data coming in, this will give us a better perspective on how should we do the so-called data storage, whether a CSV file, whether a RDBMS, whether have storing them as images or even storing them in a NoSQL like let's say a MongoDB, for example, right? So that will then be the so-called data storage. And when we look into the so-called training pipeline itself, right, then within our script, one of the pipelines that we can always define where to get the data and what are the so-called data cleansing steps that we want to perform, right? So in that case, it doesn't really must take the data from a CSV file or must take the data from a SQL Server, for example, right? Because within your script itself, you do have the flexibility to define how you want to so-called get the so-called data set for your project itself, right? And obviously, after we go through the so-called ML ops pipeline, when we perform all this training, right? And we will have an output, right? Depending on what framework that you use, right? For example, just now, as an example where I'm using the scikit-learn, right? The output is actually a picker file, right? For those who are very advanced on looking at deep learning, right? let's say I'm using TensorFlow, I'm using Keras, right? I may have a different file, for example, a H5 file, right? So typically all these so-called models, right, is actually a flat file, right? So in this case, all right, we can either store in the so-called Git repo, right, that we have over there, or we can actually store in the so-called MLOps platform that you have over there, right? And one of the common practice that I've seen is that they will actually store the model into the MLOps platform itself. The reason being is that this will give them the so-called options or the capability to perform the versioning of the model itself, right? So I'm not sure if I can toggle my screen. Probably just want to explain on this portion. Let me just share my screen again. Right, so probably I'll just go into these portions are over here, right? So typically after we complete the so-called training, the pipeline, we will have output, right? So I think just now I show you that one of the output, not this one. One of the outputs that we have over here is actually a pickle file, right? And as a common use case, I've seen that people will actually store the models within over here, because over here I'll be able to do the versioning and I'll be able to do the necessary tagging as well. So as when I want to deploy the model, it becomes very simple because it's just a few clicks and I'll be able to deploy the model, right? And obviously, just now I spoke a lot on the so-called explanations as well as the fairness of the algorithm itself, right? And this is something that you will be able to enable, you'll be able to see over here as well, right? So typically for the model, we will store in the so-called machine learning platform itself, right? But there's nothing stopping you to actually store the so-called model back to your own Git repository or store to any file repositories that you have over there, right? Ultimately, it goes back to the so-called workflow that that you envisage within your organization that best fits fit your use cases. All right. So I hope that addressed the questions. Okay. Sorry, I just saw this one. There's one comment that is a bit small. Maybe let me just zoom in for those who couldn't really see. Right. So this is the model, and we will be able to do the so-called versioning. We'll be able to do the so-called endpoint deployment as well. All right. All right. Is there any more questions? All right. Yeah, I saw in the chat that there isn't questions over there, right? With that, I hope it's a good sessions with you. So we covered, the so-called overview on ML ops. What are the tools that are available? How it looks like in action, right? And obviously also touches on the so-called responsible AI. So hopefully this is something that you'll be able to so-called bring this practice into your organizations. And I really hope to see all these wonderful so-called advanced technology get implemented within your organization. All right. With that, right, have a good evening. Have a good sessions. All right, for the rest of the sessions within the learning festivals. All right. Thank you.